Hi students, welcome all for our 5th semester classes. Let us start our classes from spectroscopy. At first, we are going to study about the general introduction of spectroscopy. Spectroscopy, the term is the study of interaction of electromagnetic radiation with matter. All of you know matter, three states of matter is solid, liquid or gases. And this spectroscopy used to determine the structure of organic compounds. So, spectroscopy is define the study of interaction of electromagnetic radiation with matter, and this spectroscopy used to analyze and determine the structure of organic compounds. Next, there are some types of spectroscopy. Ultraviolet, visible, infrared, nuclear magnetic resonance, mass spectrometry, atomic spectroscopy, etc. etc. So, by use this spectroscopy, we can find out the organic structure determination of organic compounds. Okay. Here we are see about the some merits of spectroscopy over the classical techniques. So first one is much less time. That means they take much less time. Less time is very smaller time we can get the analysis data. Second one is the very small amounts of compounds. That means milligram or microgram levels of compounds being studied by using this technique. And also third one is the non-destructive means the compounds is not destroyed or damaged during this spectroscopic analysis. So we can reused for these compounds. Next one is very fast and cheap. So this technique, this spectroscopic technique, very fast and also very cheap to analyze the compounds. Fifth one is highly reliable. That means they are highly reliable. That's very accurate. We can get the very accurate data establishing identity of two compounds. Next is the automatic or semi-automatic manner and continuous operation. By using this spectroscopy, we can get the continuous operation by the automatic or semi-automatic manner. Okay, these are all the merits of the spectroscopy. And next, electromagnetic spectrum. All of you known as the spectrum. Spectra is a color bands like all of you know the rainbow. When this is the example for the light spectrum. So here the electromagnetic spectrum means and the spectrum obtained by the electromagnetic radiation. Electromagnetic radiation means light consists of electric and magnetic field perpendicular to each other and hence called the electromagnetic radiation. So we can get the electromagnetic spectrum via this radiation. Here this table shows the some radiation and their corresponding wavelength range. For X-rays for 5 to 100 Armstrong, ultraviolet 100 to 400 nanometer, visible 400 to 800 nanometer, and infrared 2 micron to 15 micron, microwaves 1 millimeter to 10 centimeter wavelength range. These terms such as wavelength, frequency and wave number are used in express some spectral data. First, what is meant by wavelength? The distance between two successive crest or trough of a wave. So all of you know the crest of the wave and also troughs of the wave. So the distance between the two successive crests or two troughs of a wave is known as the wavelength. Next is the frequency. A number of cycles per unit time is called as the frequency. That means first wave shows the lowest frequency because the number of cycles is very low, so this is contain lowest frequency. And second one is the highest frequency, because number of cycles is very high, so this is known as highest frequency. And third one is wave number. The number of wavelengths per unit distance is called as the wave number. So these common terms are used in the spectroscopic is wavelength, frequency and wave number. Next, we are going to study about some relevant mathematical relationship of the wavelength, frequency and also wave number. The first equation shows the wavelength related to frequency is shown by this equation, lambda equal to c by nu dash. So or nu dash equal to c by lambda, lambda nu dash or cross multiply over, or c equal to nu dash into lambda. This is the relationship to the wavelength and its frequency. Here the wavelength is denoted by lambda, is the wavelength expressed in angstrom or nanometer or millimeter or centimeter, etc. And c is the velocity, that means speed, range is 3 into 10 power 10 centimeter per second of the radiation, and nu dash is the frequency of the radiation, it denoted by hertz. Okay, this is the first equation is known as the relationship between the wavelength and frequency, lambda equal to c by nu dash. Okay, that means lambda and nu dash are inversely related to each other. That means longer the wavelength, the lower the frequency. That means wavelength, the longer the wavelength, frequency is lower. So lower the frequency. This is the relationship of the wavelength and its frequency. Next is the relationship between the wave numbers and frequency and also the wavelength. First equation shows the wave number is inversely related to wavelength. That means lambda. So wave number equal to 1 by lambda in centimeter equal to 10 power 4 by lambda in micron. So here the 10 power 4 is obtained from this lambda in centimeter converted to lambda in micron. 1 centimeter is equal to 10,000 micrometers. So we can write this 1 by lambda in centimeter equal 10 power 4 by lambda in micron. Therefore, let us consider the 5.40 micron is equivalent to 10 power 4 by 5.40. We obtain the lambda value 5.40 equal to 1852 wave numbers. Okay, this is the relationship between the wave numbers and the wavelength. Next equation shows the and before the unit of this wave number is expressed in centimeter inverse. In centimeter inverse is commonly spoken as reciprocal of centimeters, because centimeter inverse. Okay, next we are going to this equation. This equation shows the relationship between the frequency and also wave number. Here the wave number is directly proportional to frequency. That means nu equal to nu dash by c equal to 1 by lambda. Okay, so here c is the velocity of the speed of radiation. Okay, so this equation nu equal to nu dash by c equal to shows the relationship between the wave number and also the frequency. Okay, these are all the mathematical relationship of the wavelength and frequency and wave numbers. Okay, in this class we are all study about the general introduction of the spectroscopy and also types of spectroscopy, merits of spectroscopy and electromagnetic spectrum, and relationship, mathematical relationship between the wavelength, frequency and wave numbers. Okay students, we will continue the rest in the next class. Thank you.